Oh yeah, we got because one of them walked off the job and then sued us during that project, and that was a mess. So that was a huge challenge.
So how did you
Uh,
address that challenge?
Documentation because I keep
Mhm.
everything. I'm very, very well organized as far as documents
Mhm.
go,
Mhm.
and so whenever he filed the lawsuit, I had
Mhm.
everything there, and so I mean I kept an engineering notebook that had all the drawings and all the meeting notes and all the design changes and whatnot. And so when the lawyers came in, the corporate lawyers came in, I gave them a big old stack of
Mhm.
papers. I go, here's everything that's involved in this project, and to make
Mhm.
copies of all my stuff. And so it tracked everything that happened throughout that whole project.
Mhm.
So, but
So what
I
kind of
wouldn't say that I
system
was
design challenges did you face?
fitting, uh, well, again, physical space, um,
Okay.
just putting machines in, spacing, uh, coding. We used ladder logic and coding the machine movement
Mhm.
to correspond with the different sizes of the pipe that we moved.
Mhm.
And a part of the system was actually a new kind of industry-changing machine that it was a different project. It was a $1 million project that kind of
Mhm.
coincided with this project. We bring in a new
Okay.
machine that was it was an industry-changing machine, and so we were testing it at that facility.
Mhm.
And so incorporating this machine with within this pipe racking system, that was
Mhm.
a challenge.
So how did you overcome these challenges? What tools and processes did you use to overcome these challenges, essentially?
Mm, Pretty much a tape measure.
Mhm.
I really I don't know how to answer this question. It was um, well, I ended up modeling the whole plant in in um, in SolidWorks. It's a CAD program, and so I modeled the whole at least that half of the plant, all in 3D with all accurate dimensions, so we can move stuff around, move machines around, and make
Mhm.
sure everything fits. Um, People usually don't do that because it's a lot of work, but
Mhm.
to make sure I got it right, I felt like I needed to do that. Um, what other challenges? Electrical power challenges. Um, if you want me to if you want me to be specific on that, we had a what they call it, we had a Y transformer, which is kind of an old style transformer that provided power to the plant. And so
Mhm.
incorporating new electronics um, or installing new electronics on an old style of power grid was a challenge.
Okay.
Um,
Again, how did you resolve this?
with grounding rods, we went
Mhm.
around because with that type of system, it liked to short out and short out
Mhm.
the system through the ground. It was jumping through
Mhm.
the concrete and it was shorting out the system. So we added in grounding rods on all the conveyors and
Mhm.
the electronic components so that it wouldn't jump through and short out the system. And that seemed to work.
Okay. Okay. And in terms of like the system design project, um, in terms of that particular project and the new infrastructure, the new machinery that you had to kind of like adjust, were you able to successfully deliver this project within budget, scope, and within the timeline that was given?
Which, which project?
The racking system project.
Oh, um, within reason, yes.
Mm-hmm.
Um, I think we went over budget a little bit. I think
Mm-hmm.
it was. I mean, it wasn't too bad. As percentage-wise, I think it was mm, it was under 10%. So
Okay.
so 130,000 out of 1.3 million. I think that's pretty good.
Mm-hmm.
Um, I think we were a
And
little bit
in
over
terms of
budget.
like managing the contractors and everything, um, I mean, you were able to do that seamlessly.
Yes, switching out contractors. Um, I think, and that's what caused us to go over budget.
Mm.
Once the contractor that did walk off the job, um, I immediately called. I got a name for another supplier from somebody. He's a guy
Mm.
that usually does a lot of the work. He came in and then knocked the work out in like 3 weeks. Um,
Okay.
so so yeah, we were on time and a little bit over budget.
Mm. Okay. And in terms of so this was one project that you worked on when you first came on board. So what kind of teams did you or what was the size of the teams that you led here, Steven?
It was me.
Okay.
That was it.
So you were working on these
Well,
projects alone?
I was by myself. Well, I guess the VP of operations
Mhm.
it was me and the VP of operations, which was my boss. That was it.
Mhm. Okay. Okay. And did you interact with the clients directly? Did you kind of like, what about the client requirements, information gathering, etc.? How about that?
Well, with the clients, so my vendors, yes, um, yes, I did communicate with them directly. Um,
Okay. So
and yeah,
these products that you were designing, these engineering products, these were for different vendors. I mean, who were your key
yes.
clients essentially?
So they so we were the client, and I had vendors
Okay.
um, designing and manufacturing the system for us for our plant. Um,
Mm-hmm.
and so we were really the customer for this project. Well, actually, pretty
Mm-hmm.
much for everything. When this as a project engineer for that position, uh, I was always the customer, and I had these vendors doing things for us. Um,
Okay, so you designed the products that were needed for the company, and then you would kind of like
conceptually,
give them to the vendors to manufacture them, right?
what to engineer them. So
Yeah.
we did
Mm.
the conceptual design, and then we contacted other engineering firms to build it for us,
Mm-hmm. So
to
kind of
engineer and build
outsourcing
for us.
the engineering aspect.
Yes.
Mm-hmm. Okay. And you
And
mentioned that
and
you
so
also. Mm-hmm.
yeah, so it was more of a well, yeah, it's like buying a product from somebody, and I'm not sure if you'd call it outsourcing. We went to an engineering firm that built certain machines,
Yeah,
and
you.
so
I mean,
I
you work with
managed.
external vendors.
I'm sorry.
I said you worked with external vendors for the manufacturing or the engineering process, right?
Yes.
Yeah, okay. So,
Yeah.
Steven, you also mentioned that you designed a compact pipe kickover assembly for a pipe trolley system.
Yes.
And you designed 9 carts and material handlers that were being used globally. Tell me more about this project.
Okay. The compact lifting arm that was for a different conveyor system at one of our at a different plant. And so
Okay,
that project right there um, was 100% me. Uh,
okay.
um, I didn't. There were no vendors involved,
Mm.
and so from beginning to execution, that was all me. So I'm actually kind of proud of that one. And through the
Mm-hmm.
conceptual, the engineering, um, the research, the um, suppliers, and then or at least the material, supplying the material, and then we built that in-house. We built
Mm-hmm.
that in-house and then installed it in-house.
Right. And how big was this project in terms of the monetary value?
A couple $1,000. Well, no, I wouldn't say that. If that was designed and engineered and manufactured from a different company, I would guess that would be a $50,000 to $80,000 or more, $100,000 project. But I did it for much less. We had the materials in house. We built it in house, and
So you kind
so
of helped save cost as well.
oh yeah. That was
Mm.
actually that's a good one. I probably saved the company a whole
Yeah.
bunch of money on that one.
Because
And I did it for
as an
$2,000.
engineer, cost saving is one of it's a very good aspect, right?
Actually, that's a good
Okay.
idea. Yeah, we should focus on that because I probably
Yeah.
saved the company, $50,000 to $80,000 on that one.
Right.
I mean, they paid me
Okay.
to do it. I don't know how many man hours I put in on that. That was several years ago.
Mm.
That probably took me about a
Mm.
month.
Okay.
It took me about a month to design that, and then just a few
Mhm.
weeks to build it and implement
Okay.
that.
And any
So
particular design, manufacturing, or testing and implementation challenges that you faced?
it was a 4-bar linkage. Could use
Mm.
that one. It was pneumatic.
Mm-hmm.
It's hydraulic. Oh, I don't remember if it was a pneumatic or hydraulic. It was one of the two. 4-bar linkage. I think that's probably all the terms that I really know. Well, yeah, I did testing. We did simulation. I did simulation testing on the CAD program.
Mm.
Stress and strain evaluations,
Mm.
and I picked out the material, the thickness, and the specifications for the material.
Okay.
And then I put a bit of, and I put together a whole design package, kind of like an IKEA instruction manual for this. I do that for most of my stuff. A whole design package with bill of materials,
Mm-hmm.
and part cut sheets, and I sent that to the plant that, or I sent it to another the manufacturing part of a different plant. It was one of ours,
Mm-hmm.
and those guys put it together, and then I flew down there and made sure they installed it right. So even that's part of kind of factory acceptance testing, but it was in house.
Mm. Okay.
And then another one. I mean, if you're satisfied with that one, there
Yeah.
is another one that was very technical. It was
Mm-hmm.
these quick change dies. I'm not sure if I mentioned that
Mm-hmm.
in that form you sent me. It was tooling. I designed tooling for a swedge, SWAGE.
Mm-hmm.
It was a 50-ton swedge, and
Okay.
designed the tooling to decrease tool change-out times because
Mm-hmm.
they were very, very heavy, and tolerancing. So again, one of the challenges it was with tolerancing, the tolerance
Mm-hmm.
between the dies, and then another challenge was having a person put these heavy blocks and tools in the machine. And so I designed these scissor tong lifting device
Right.
to,
And you
to lift
designed
with
that
a
again
crane.
on your own?
Yes.
Okay. Okay.
Again, with the material and the surfacing to make it real slick so they can push it in and out.
Mm-hmm.
But we had I mean, that was made with raw material too, so I had to call vendors with specifications for a certain material that had to be forged and heat treated, and then send that out to another vendor of mine that I had a pretty good relationship with, and had him mill those out. And then the tongs, the scissor tongs, we made those in-house. I followed the same process I did with that compact lifting arm. Because that was a solution that there was no solution to, or no no pre-made solution. So that was part of an innovative solution of mine that I designed and had our guys build in-house.
And Stephen, is that the same thing that you mentioned in the resume, where you mentioned that you designed and managed the modification of a pipe clamp system for a 500-ton sewage, right?
Yes, that's the same one.
Okay. And in terms of, once this was implemented, once this new tool was implemented, supporting tool, what results did you see? How did you see the before picture altering to the after picture?
It cut down tool changes by half.
Half, right. And definitely, improved, like made the process more efficient, since now you did not require manual labor to kind of like move these heavy blocks.
Yes. And it also identified, because that was a bottleneck in the process, and so by doing so, by modifying this machine, we had to it identified other bottlenecks that we could provide solutions to make the process even faster.
And you prepared all the drawings, and you kind of like prepared the specifications and everything for this particular this new and innovative tooling, basically tool, essentially, right?
Yes.
Okay. And in terms of and how long was this project, Stephen?
That project took about oh man, that was a long time ago. 3 months maybe.
Okay, 3 months. And you also mentioned that you designed these 9 carts and material handlers that were used globally. What was this about? I mean, why were
so everything that we did in that plant was very heavy. All the material was very heavy, and so it was for a drill pipe casing and accessories, and so these parts would come in on a pallet, and somehow we had to get these into a machine and carry them all around, carry them around the plant in different processes. And so to do so, I had to find out what the standard sizes are on these pallets, and design a cart that's ergonomic enough and that's sturdy enough to hold these parts. And some of these parts were 6,000 pounds. Because we didn't. I mean, some things were carried on the forklift, some things the machine operators physically pushed around. And so I used OSHA ergonomic standards, and for these carts. It wasn't a big project. It was also it's probably my second project, coinciding with that racking system.
Okay.
And so that wasn't that big deal, but I provided drawings, and so the company wanted a standardized drawing so that they can distribute the drawings to other sister companies and different plants around the world. I think they're used in Egypt and in South Africa and some other places.
This is a good aspect. Yeah. So, I mean, were you able to produce the standardized, design template or these standardized drawings at the end of the day?
I'm sorry?
So I said, were you able to produce these standardized drawings at the end of the day?
Yes.
Okay. And
Yep.
how did that again improve the whole picture? What results did you get?
Oh, that it was, I guess, timing, the speed at which the machine operators can move parts around. Because normally you'd have to have a
That improved
forklift.
efficiency, right?
Yes.
Okay. And by how much? Do you have like a rough percentage estimate?
No, I don't. A rough estimate? Oh, it was a small part of the process. It was a very, very small part of the process. So, I don't know, 2%. I don't know. It was a very
Okay.
small part.
Okay. But this standard was used across the globe for in your sister companies, right?
Yes.
Okay. What else? You mentioned that you also designed and implemented a 7,000 CFM ventilation system and a
Yes.
contraflow rinse system for again phosphating lines. So tell me more about this project.
Okay.
What specific challenges did you face? Again, what results were you able to get? What tools and processes did you use?
Okay. That well, before I go into that, that project was not complete. They
Okay.
threw me on to a different project before I could finish that one.
Okay.
Well, okay, so the contraflow, I did complete that, but that wasn't my design. That was designed from our parent company engineering department. I just I implemented it.
Okay.
Um, I did do some design work on that because this was it was a phosphating system to where they would submerge the parts in different liquids. And there was 7 different tanks that they would have to dip these parts in, and in the rinsing system, I mean, I won't get into that's anyway. It was the tanks that we used were different from the tanks that the engineering department specified. So I had to adapt the same concept onto existing equipment. And so I did
Okay.
do some design. I did do some design work and had that modified. And I did specify materials, sizes, pumps.
So you led the
The
change management essentially.
yes, yes.
Mm-hmm.
And anyway, I specified all the technical details and all the parts and materials and whatnot. So I did complete that one.
And you were able to successfully incorporate these design changes, right?
Yes, yes.
How did that improve? I mean, what results did you get?
Okay, so that improved quality. That was a quality control
Okay.
process that
And
was
how much
improved.
did you improve that?
As a metric, that improved. Well, again, I don't have numbers. God, I should grab those numbers before they got rid of me. I don't know, a qualitative number.
Okay,
I
that's
don't
fine.
have
I
one.
mean,
I don't have one. But it improved just the quality of the coating, and recoding. So I mean, if a part didn't meet the quality standards at the end of the process, they would have to sandblast it and do it over again. It did reduce it probably cut that in half, or probably got
okay.
yeah, I'd say cut that in half because of the rinsing process.
So it kind of also improved the accuracy of the coding process, right?
The efficacy, I wouldn't say that the efficiency was more effective than it was efficient. So it improved the efficacy of the process.
And what about the ventilation system project?
The ventilation system, I got halfway through that project before they canceled that project.
Mm-hmm.
The challenges were to well, the purpose was to capture steam that came off the tanks, and you do that by putting some kind of vent hood above the tanks. But the challenge was that we dipped parts in from the top, and so we had to suck the steam from the sides. And so I designed a whole system for that and drew up drawings but I never got to test it and never got to implement it. So, but I put that in there because I had a vendor come out to quote an installation of the project, and I told him how I did it. And this was an expert in the ventilation field, and I told him how I wanted to do it, and he goes, "Wow, I've never thought about doing it like that." And he's like, "That might work," but then I never got to prove that. So
you kind of like went till the coating stage, right? And then you had, I mean, then you just shifted from that project.
yeah, that project was canceled. So maybe we shouldn't put that in there.
No, I mean, we could kind of like talk about the design aspect
Okay.
only, and
Okay.
we could talk about that. Okay, these are some good project examples, Stephen. In terms of like managing the